Boca Chica, Texas, April 20th, 2023. To the cheers of SpaceX staffers, Starship clears the tower as it roars off the launch pad.
Booster after chamber pressure is nominal.
A critical first test of the biggest rocket ever built, with twice the thrust of the Saturn V rockets that lifted Apollo astronauts to the moon.
Going through the period of maximum aerodynamic pressure.
They'll need the power if Starship is to one day send astronauts to the moon and eventually Mars. But only 3 minutes into flight, the rocket booster failed to separate. Then, 4 minutes into flight, ground controllers hit the self-destruct button. The crowd cheered that Starship had gotten this far. Seated in the control room, Elon Musk had warned the chances of success were really only 50-50.
Starship just experienced what we call a rapid unscheduled disassembly.
Not only did it disassemble, the force of the rocket destroyed the launch pad itself. Yet despite a bad start, both SpaceX and NASA insist they're committed to Starship. First to land astronauts on the moon, but ultimately to carry astronauts to Mars as soon as 2040, eventually building human colonies. In 2021, Elon Musk told me humanity must reach for Mars and beyond if we are to survive.
I think it's important that humanity become a multi-planet species and that we extend consciousness and life as we know it beyond Earth.
And there's another motivator, China. U.S. generals warn China appears determined to create a military presence in space, starting with the lunar surface. It's already built a robotic base on the far side of the moon, with plans to land its own astronauts by 2030. On Mars, only the U.S., Russia, and China have successfully landed robotic rovers, but the U.S. has had far more success. Washington State Democratic Congressman Adam Smith is the ranking member on the Armed Services Committee. Is it imperative that the U.S. gets to Mars before Russia or China?
You know, China's a major power, we're a major power. If we stumble into conflict, that has huge negative implications for the entire planet and for space as well. But in the short term, yeah, we need to be competitive here. China, I think, is very aggressive. President Xi Jinping has made it clear that he thinks that the U.S. is a disappearing power and he wants to replace us. So that competition is real in a lot of places, and certainly it's real in space. It's real in the race for the moon and in the race for Mars.
Now, NASA is preparing to send astronauts back to the moon and eventually Mars, but faster. A round-trip mission to Mars could take 2 to 3 years. Just keeping a crew fed would be a massive challenge. Then there's the risk of prolonged exposure to fatal doses of space radiation. So to cut the travel time, America is going back to the future.
This project was called NERVA, Nuclear Engine for Rocket Vehicle Applications.
To the 1960s and a government program most Americans have never heard of to develop nuclear-powered rockets.
Someday, a manned trip to Mars and return may become the mission assignment.
It turns out they made big progress back in the 60s, running big, expensive tests.
These tests will complete the technology for a nuclear rocket engine.
DARPA.
Fast forward to today, and NASA and a Pentagon department called DARPA, the Defense Advanced Research Projects Agency, are going back to their grandfather's programs 50-plus years ago.
3, 2, 1. Boosters in ignition. And liftoff of Artemis 1.
The goal, sending astronauts to the moon and beyond on nuclear rockets.
Look at the clarity of this. Look, this is a star nursery. This is the cosmic soup that creates stars. And
NASA Chief Bill Nelson.
Future missions will have international astronauts. We go openly back to the moon and then to Mars. The Chinese government is very secretive, and a lot of their plans involve their military preparations. And so there's a reason for us to get there first, and that's what we're going to do.
Why go nuclear? Because from the earliest days of Mercury, Gemini, and Apollo to Artemis and SpaceX, rockets have relied on liquid fuel, which burns up quickly. When the Apollo astronauts went to the moon, they needed 5 of these massive F-1 engines just to get them off the Earth and escape the Earth's gravitational pull. 7.5 million pounds of thrust. Here at the U.S. Space and Rocket Center in Huntsville, they've got an exact replica to scale of the Saturn V, 363 feet tall. Future astronauts will need that kind of lift, but once they're in space, they can use a much smaller engine, a nuclear engine, to go all the way to Mars and back, a fraction of the size. And that engine could last 20 years. Wow, this is a big place. It's happening now at the Marshall Test Flight Center in Huntsville. It's not just theory. So what is this here? This is a nuclear test chamber.
This is where they put components of nuclear thermal rockets, such as this fuel element here, and like the one that you're holding.
These are the building blocks for America's future nuclear propulsion going to space.
Yes.
DARPA program manager Dr. Tabitha Dodson has pulled out the old blueprints and dusted off the test engines from the 1960s. But in the early 70s, the government canceled the program amid public concern about nuclear safety. Fast forward to today and an added geostrategic imperative.
We need to look at what does the United States have which gives us that leap ahead advantage over our adversaries and our near peers.
The Chinese?
The Chinese and others. So we don't want to be on par with our adversaries. We want to be ahead of them. And we have the means to do so.
And this is it, nuclear?
Yes.
Energy from fission is...
And it turns out the U.S. appears to be light years ahead with nuclear rockets. Today, Dr. Stephanie Tompkins leads DARPA, created after Russia's Sputnik satellite caught America by surprise.
Well, the technology from the 60s never was given a chance to achieve its full potential. So a lot of amazing work went into it. When I go back and I read the reports from those days, I am continually reminded that we all get to stand on the shoulders of giants.
For the first time, men from Earth will set foot on another planet.
Today's nuclear rocket program, called Draco, is different. Inside the rocket, a small nuclear reactor with graphite elements. Rather than using weapons-grade uranium, it uses high-assay, low-enriched uranium, common in research reactors, and capable of generating tremendous heat. Liquid hydrogen moves through the channels in the core, heating to 4,000 degrees. That gas is then shot through a nozzle to provide thrust. 330,000 gallons of fuel to fire for 30 minutes for a mission to Mars. A nuclear rocket's much smaller propellant tank, able to carry much heavier cargo, traveling faster and further.
So using nuclear thermal propulsion, it'll cut down travel time by at least a third of the time.
So that's cutting days out of the trip to the moon and months out of the trip to Mars.
Yes, exactly.
That's valuable time.
It is.
Can we sustain human life in a crew all the way for 2 years the first time we go to Mars? That's pushing it. So if we can get there faster, then that's what we need to do. And that's what this nuclear propulsion will do. And it's safe.
NASA and DARPA insist the rocket's nuclear thermal reactor will never be tested here on Earth. So the Draco test will happen in space, the first since the 1970s, scheduled now for 2026 at a safe distance from Earth. If there were any sort of a nuclear accident in space when you're testing this, could that radiation come down to Earth?
No. So we have chosen our altitude such that we are far away enough from the Earth, and the farther away you get from the Earth, the longer you stay in space, that we will stay put in space long enough such that those radiation products will never make their way back to Earth.
For hundreds of years, they would stay in space.
Yes.
Okay, but how likely is it that humans, Americans, will actually travel to Mars by 2040, as NASA suggests? And do we really need to send humans to Mars?
As an astrophysicist, we figured out some decades ago that I could send you or I can send a robot to this destination.
America's best-known astrophysicist Neil deGrasse Tyson is skeptical.
I'm all for people in space, but to accomplish scientific goals, the robot can live off of sunlight and you can't. Robot is not going to cry because we ran out of money, we can't bring you back.
You don't see this happening in the near term.
Correct, unless there's a geopolitical force operating, such as what happened with Sputnik, okay? What would that be? China says, leak a memo saying they want to put military bases on Mars. We're there in 12 months. 3 months to fund, design, build the spaceship, 9 months to take it there.
But Elon Musk is all in.
We need to get Starship operational in order to have a base on the moon and be able to send people to Mars.
Musk has plans to build a colony on Mars. Back in 2021, he talked about his hope for his Starship to carry humans to the moon and then the red planet. Because gravity on Mars is just a third of Earth's gravity, a rocket would not need as much power to return to Earth. Musk's plan is to reuse rockets just like airplanes.
The risk is not zero. It's a hard thing to accelerate, put so much energy in something and then take it out on the return. It's a very hard thing. So it's one of the hardest things. So you just can't get to zero risk. We'll do everything we can to get as close as possible to zero risk.
Just as Sputnik lit the fire for America's space program, China's ambitions may be having a similar effect today.
The fact that we now have a very aggressive competitor, I think all the more makes it a space race.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.